So everybody had a good first day at CppCon? You say that now. Wait till Friday when you haven't had any sleep for a week. All right, so tonight we have a panel that gives us an opportunity to talk to, learn from, and maybe hold accountable the representatives of our the committee that develops the standard that is C++. And this is about your questions to this panel. And so we have 2 microphones, and I'm going to urge you to participate by coming to the microphone and making your questions. Do we? Yeah. Okay. I'm gonna kick it off to ask the panel members to go ahead and introduce themselves. But more importantly, I want to know what their role is in the committee. Now, some of you have specific positions on the committee. I want to hear that, but I also want to hear what you think your role is in terms of it's my job to do what. And so we'll start over here with Vittorio.
Hello, everybody. My name is Vittorio Romeo. I work at Bloomberg. I'm one of the newcomers to the committee. I've been to 3 meetings. I'm mostly interested in evolution, but I also have a paper called Function Ref, which has been going through library, and it will be probably in C++ 23. And I'm also planning to stir some controversy at the next meeting by proposing something like Rust editions for C++. So you can ask me about that.
Hi, I'm Hannah. I'm working in Avast, and I'm a Czech national body. And obviously, I'm incoming compile-time programming chair.
Hello, my name is Bryce Edelstein-Wellback. I work at NVIDIA. I am the chair of the tooling study group and the library evolution incubator group. I guess I view my role on the committee as helping to ensure that we have a standard library that works for users and that also works for implementers. That's something that we can actually ship. And also ensuring that concurrency and parallelism remain great and up with the times and the standard.
I'm JF. I'm newly the Language Evolution Chair, formerly the Language Evolution Incubator Chair. And I view my role as shipping the language side of 23 that's good.
I'm David Stone. I work on autonomous vehicles at Uber. In the C++ committee, I am the chair of the module study group. And I'm also the incoming vice chair of the evolution working group. I kind of view my role on the committee as fighting against Conway's law, which states that an organization is constrained to produce designs that mirror the communication structures of the organization. So I try to make sure that I go around between a lot of different groups and kind of understand what's going on and communicate with people that I normally wouldn't talk to.
I'm Titus Winters. I'm Google's C++ library lead. And on the committee, I chair the Library Evolution Working Group, which is the group responsible for the design of the standard library. And I view my role on the committee as trying to force us to think on a 5 or 10 year time frame instead of just focusing on the next meeting. So a lot of the papers that I write are not proposing new features, but are, hey, what are our priorities?
Bjarne Stroustrup. I'm a member of the direction group. That's probably my only formal position. I try to focus on coherence and consistency of the language with moderate success, and trying to stop us from going in all possible directions at once.
Marshall Clow, I am the Library Working Group Chair, and my group is responsible for the exact specification of all 1,000 pages of the standard library. In the rest of my time, such that it is, I am the code owner for libc++, the LLVM implementation of the standard library. And in the rest of my time, I attempt to sleep occasionally.
I'm Lisa Lippincott. I'm the Chief Technical Architect at Tanium. I came to the committee mostly because I'm very interested in the ability to write provably correct code, and I would like to push C++ in that direction. In the meantime, I've been working with the numerics group and with the group on undefined and unspecified and undefined behavior and software vulnerabilities, which is a bit of an enigma wrapped in a mystery. And starting in November, I will be the chair of SG6, the numerics study group.
I'm Herb Sutter. I've been working in and writing about C++ for some time. I guess I started out writing mostly about how C++ works, and isn't this an interesting, complex gotcha? And now I'm mostly interested in reducing and removing gotchas. So some things come full circle.
All right, thank you. Do we have a question over there?
Yes. Ooh. Hello, everyone. My question is, what...
Can you first tell us your name, Guy?
Yes, I can tell you that. My name is Guy Davidson. I also frequent the committee occasionally. My question is, what is the difference between a C++ programmer who is not on the committee and a C++ programmer who is on the committee?
I don't know. What is?
There's at least 4 million that aren't. And they are more diverse than you could possibly imagine. And most of them think we've got our heads stuck in the clouds.
I think a reasonable first cut is your answer to why is this a mess? It's complicated. Right? Like, everyone that doesn't sit in the committee comes to us and says, "You're so dumb, why is this so bad?" I'm like, well, you weren't there and you didn't see all the other options. Like, trust me, we're trying real hard. It's just complicated, yo.
Yeah, I think one of the main differences is that sometimes on the committee, we're all experts at C++. And sometimes, most of the users of C++ are using C++ to solve some sort of problem in the real world. Whereas I think sometimes on the committee we can be focused on the language itself instead of the problems that we're solving. That's kind of both a good and a bad, our expertness in C++.
I agree with all of those. One other I'd throw in is we tend to live in the future. And that sometimes creates a disconnect because it's very easy for us to think about features that are hot right now and are being actively developed, which means that we'll standardize them in a few years and then people will be able to use them a few years after that. It's not something necessarily people can use today, although sometimes there are approximations and things like that. So it's hard sometimes to not have there be a disconnect and to remember, even as we're looking forward and trying to improve things, that often our heads are 3 to 5 years from now, and to stay connected to what's now so that would be one difference and also a challenge, at least for me.
Yeah, I think I agree with what Herb's saying. I'll tell people at my work or my user group, oh, we're working on this thing. I think you'll be able to use it in 5 or 10 years, and it's just mind blowing to them. But on the committee, those are the sort of timeframes that you think about, because when you're working on a project that is used by so many people, roughly 5 million programmers, it is not necessarily easy to roll out changes.
We have to think that far. We cannot get confused and think that the only thing that matters is the next release, which is the developer mindset. On the other hand, we cannot just have our heads stuck in the cloud and think in 10 years' time, because one of the fundamental rules of evolution is that you have to be viable at any point in time. Short term, long term, medium term.
Okay, can we take a question on this? Is there a question on this side?
Hi, I'm Zhihao. My question is, when I was reading the design and evolution of C++, I found that eliminating the usage of preprocessor usage was one of the language design rule. Do you think, after 25 years, do you think it's still feasible? And if yes, where we are?
You want to know whether I think we can eliminate the preprocessor? No, and I'll tell you. So I am one of the rare people on the committee who actually likes the preprocessor, and I'll tell you part of my reason for it. Pretty much every major language feature that we've developed in the past 10 years, at some point there's been some prototype non-compiler-based version of it that's relied heavily on macros. I think we might eventually replace the macros that we have with better macros, but there's a quote that the only thing faster than standard C++ is non-conformant C++. There's tons of different language extensions out there, or features that maybe someday in some form will be in the standard, but they're not today. And so if you have a cross-platform code base, you need something like textual macros. So I will now receive the hate of my colleagues. Who wants to go first?
And you were wanting fire up here.
I'll take a counterpoint to that, which is I think that over the years we have done quite a lot to reduce the amount of use of the preprocessor that you need. We go through routinely looking at things and saying, yes, people have to use the preprocessor for that, and we would rather they had something that worked better, because the preprocessor will do a lot of things, but it does almost nothing well. So I think we have actually eliminated a lot. I don't know if we will ever eliminate it all.
Couple of points here. I think macros are addictive, and addicts are very hard to wean off their drugs. One of the major problems about macros is that it stops us from having decent tools. This is why C++ browsers and the tool set is lousy compared to certain other languages. That is because the compiler looks at one thing and the humans look at another. And in between is a text processing system. That's bad, and that's a major harm. That said, we are trying to eliminate the need for macros. We're getting modules, templates are getting better. We're getting intrinsics to give us a line and file name and things like that. So we're getting to the point where you actually can write a lot of your code without using macros, especially if you're not deep down in the implementation of libraries where you have to deal with curiosities in the hardware. On the other hand, that doesn't dissuade the addicts because they really love them.
There also are more concrete examples about this that are coming in the future. As an example, if you look at consteval, we have that for functions now, but in the future we might have consteval variables, which might replace things like macros used as constants. Also, if you look at a proposal by Jason Rice, if I'm not mistaken, which is called expression statements, that's supposed to be a namespaced AST-based macro facility that would be hygienic and clean. So to answer your question, I would say it would take a lot of time because macros do a lot of things, and each single thing has to be replaced with a feature that satisfies the user, but there's definitely work being done in that direction, and we would appreciate your proposal to fix it as well.
I was going to say that at least in the code I work on, we have an awful lot of preprocessor use. but we try really hard to bury all of that in very specific places. The standard library has a whole bunch of if-defs based on the C++ version because you have to support certain features in C++ 14 and certain features in 17 and so on. But all the rest of them we try to bury in very specific things and very localized rather than spread them throughout. And that has worked very well for us. If you localize the places where you have to use the preprocessor, then they're easy to change. If you have them on every third line, then you just, when the time comes to update them, you just throw up your hands and say, oh, this is too hard.
Does anyone have a suggestion of a particular use of the preprocessor that they think is about to go away or about to be made obsolete by something that is coming?
I'm really hoping that file and line go away with source location.
I went to a talk about reflection, and one of the big uses of the preprocessor is to do reflection, and we may have that in 23.
In other words, we're working on it. We've been working on it since before DNE.
I think the most common use of the preprocessor is for hash include and include guards. And in C++ 20, we're getting modules.
Okay. I think it's time to come over here. Ben, can you tell us your name?
Yeah, my name is Ben. Ben Dean. So we've heard a lot about big ticket C++ items for 20 that mostly begin with CO. What are some of the smaller underappreciated features for 20 in your opinion?
The test method on atomic flag.
I'll give you two on containers. Contains for associative containers and consistent erasure.
I'll give you one. I really like it. Is the familiar template syntax for lambdas, where you can use the angle brackets in lambdas. And it's very nice because, for example, you can now expand an index sequence without having an extra layer of indirection in your, like an extra function. So you can do pretty cool stuff with it.
Here's one I've been working on for 3 years, and it just barely made it. We're going to have traits for testing for layout compatibility and correspondence in the common initial sequence of structures, and also for dealing with pointer interconvertibility.
Class non-type template parameters for me.
The deduction of types for templates from their constructor initializers.
I'm excited for Bitcast, including constexpr version. It's fun.
Construction of aggregates with parens.
The stood identity function object, which I just learned about yesterday, it's pretty useful.
So, and JF, are you excited about the partial departure of volatile?
Well, he asked for features.
Okay. One could say that removing is a feature.
Removing volatile is nice. Come Friday, 10:30 a.m. to learn more about it.
There's a new attribute. It's called no unique address. You can put it in your data members, and it says that they don't have to have a unique address, which implies you don't have to use the empty base optimization anymore and abuse inheritance, which is quite nice.
As a standard library implementer, I can tell you that every standard library out there has some weird thing that emulates something like has no unique address, because frankly, who wants to store an allocator in every vector when stood allocator doesn't have any members? A vector should be basically 3 pointers and an allocator, and if the allocator has no members, it shouldn't take up any storage. So every standard library you use has some hack to make sure that that allocator doesn't take up any space. Has no unique address is a way of standardizing that. Also, unique pointer or shared pointer or whatever.
Constexpr vector.
Constant it.
I think he specifically exempted things that start with CO.
He started it with constant.
Oh, yeah, it's all your fault.
Atomic float.
It's very hard to see how to get all of these features to work together in a coherent and understandable manner. I think that one of the things we have to do over the next 3 years is to think a little bit harder about how these things work together. Like we have ranges, but we can't use a range as an argument for a constructor and things like that. We have a lot to learn about these little features working together.
So that's actually the main reason that I like the aggregate initialization with parens, because I feel like it works better with parts of the standard library, like in place back. You right now in C++17 you can't in place back the values that you want to put into an aggregate. So I feel like this kind of helps the language and the library work together a little bit better.
All right, over here.
I am Jefferson Carpenter. What is your favorite C++ language feature?
I'm going with this because Juan is not here, is he? Juan from Bloomberg has a shirt, a T-shirt. It says, "Behold the power of my C++ garbage collection mechanism." And it's a closed curly bracket.
Yes, years ago, I was asked this question, and I said that my favorite feature was autopointer, because autopointer brought together everything that was great about C++, and in doing so, made my memory management issues go away. These days, I would say unique pointer because it brings together even more about what makes C++ great, and still makes those old memory management issues go away.
Transform, reduce.
Unique pointer is great, but it's still a pointer.
Overload sets and maybe type aliases. And murdering JF. Because he spoke the bad word that is ADL.
The ability to write abstractions that are still high performance.
Template metaprogramming.
Constexpr metaprogramming.
All right, we're over here now?
Hi, I'm John Freeman. In every talk that I've seen Bjarne give, he talks about education and teaching newcomers to C++. And I'm coming back to C++ after about 5 years away, so I'm kind of a newcomer all over again. And I think one of the biggest pain points for me and probably a bunch of other people is dependency management. If I see somebody's cool new library, maybe at CppCon, and I want to try it out, figuring out how to do that is pretty difficult, and everybody's got their own way. So is the committee doing anything to handle dependency management, to touch on that? And separately, I would like to hear how Bjarne teaches his students to manage their dependencies.
I'll go first. I don't. My students are budding academics, and academics don't understand about dependency management. So I escape. This is a frivolous answer, but it's a way of saying, yes, it's a very important problem, and I don't personally have a solution. Our tools group are looking into that.
So I think part of the problem here is that what some people expect of the committee is that the committee will provide some standardized solution to dependency management and things like package management as well. And we've talked about this and on the committee in some SG15 meetings. And I think as soon as you start exploring this, you quickly realize that this is not feasible for a language that has such diversity in implementations and development ecosystems as C++ has. We will never have one unified dependency management solution for all C++ programmers, because I don't think we can build something that will satisfy the requirements of all programmers. And not even that, I don't think we can build something like one solution that will satisfy the requirements of even a majority or even a large number of programmers. I think what we need to focus on is figuring out, how, there are existing ecosystems out there. There are existing dependency management solutions. We need to figure out how we can better enable them to succeed.
One of the things I said after Nico's talk on style guides all conflict, like there was a suggestion in the style guides discussion of the committee should just have one style guide. And I'm like, no, right? Not only no, but like really no, because we have such like disparate like usage requirements, right? The major axis that I would say we're gonna fight on if we tried to sit down to have one style guide is your code, are you optimizing for short-term, fast, I need to write a bunch of code, or are you optimizing for long-term, this needs to be updatable and upgradable and maintainable and readable, right? And both of those are perfectly valid use cases, but are completely disjoint subsets of the language, right? You also can't have one dependency management ecosystem that is going to, you know, serve well people that just want to grab 20 packages, have them work together, throw something together, and be done. Like, okay, I've built it once, done forever, versus someone that needs to build 1,000 packages together and keep that working every hour on the hour for the next decade, right? We don't know how to meld those two worlds together because, as I've said in many talks, time is hard. And in a language that prioritizes so greatly performance, right? We cannot take all of the shortcuts that other languages tend to like paper over, like, oh, we can make that backwards compatible. It's just a 20% overhead, right? There's no room, there's no budget for that, right? And so instead of providing a bad solution, we just don't provide a solution. And that's unfortunate, but that's the tool that we have, and that's working as intended.
Just so it doesn't sound like you're all just saying no, I want to say yes a bit. I think we can't mash all the use cases together, but there's key things that we can do to make those separate solutions eventually less separate and different. Like modules, I think will help a lot. Stuff like reflection and constexpr will help not having random things in your build system being invoked at compile time. I've worked on a code base recently that invoked Ruby, Perl, JavaScript, a bunch of other stuff at build time while building C++ to generate C++. So like if we can reduce the need for that type of stuff, I think having then different solutions for package management won't be as painful because they won't be that different at the end of the day, and the packages will be effectively the same anyways.
And I agree with the comments that there is no Uber solution, with apologies to David, but it sounded like what you were just talking about was primarily acquiring a library. How do I even just get a library, say from GitHub or install it? And some of that is getting better. So Conan, VC Package, especially for source libraries, are getting better at package management installation. Binaries harder, and release management. Package X needs version 2 of package Y needs of package Z. How do you manage that and how do you upgrade everything is still difficult. And of course, build systems have a glorious variety, and there are more new ones being built. So agreed in general with the problem, but we actually are seeing for at least some scenarios, including initially getting source libraries, that actually has improved quite a bit in the last couple of years with package management that we didn't have at all before. We now have some.
And I just want to be clear. I want to echo what JF said. I'm not saying this isn't a problem that we should solve. I'm just saying that I think one of the most important things that the committee needs to be doing in the next 10 years, making it significantly easier to use third-party libraries. All I'm saying is that I think the solution to that problem is not one global, package manager or dependency manager. It's figuring out how do we enable things like VC package and Conan and other system package managers to succeed.
Like not having a single sort of set of coding rules. I don't think we're going to have a single set of build tools or dependency management or something like that. But we can and should and do try to make the simple cases simple. That's a very good fundamental thing. We should not stop getting a feature just because we can't handle all the hardest cases. There's a lot of common cases that apply across the spectrum, especially for just downloading something and trying it out. That would be really nice if everybody provided an easy way of doing that.
And we are with, there's work in SG15 on this C++ modules ecosystem technical report, which is sort of a new thing for us. Essentially, it's a separate document that a bunch of the implementers are working on, and in some part of that document we'll talk a little bit about, I don't want to say package management, but I'm going to say like build metadata exchange. And I think we'll see how this effort goes, but I'm hopeful that that effort and potentially more in the future will give us sort of a new way for implementers to come together and agree on not necessarily solving a problem in the same way, but agree on solving a problem and solving a particular problem in some way that makes sense for their platform.
I've lost track, but I think we're over here now.
My name is Dong Lee, and my question is, what are some of the pitfalls that could harm my growth as a student who is pursuing computer science?
I don't think there are too many pitfalls if you just try stuff out. Like computer science is not a magical thing with a one-size-fits-all. I'm a mechanical engineer by training, so I think the community is trying to get better at welcoming people who do different stuff, right? Like I was pretty privileged to be able to just go into CS. I think we as a community document what we do much better and make it easier to access. So I don't know. Like we in the committee do very specific things. I think we're all kind of language nerds or really excited about teaching or compilers or something like that. We're not necessarily representative of what you can do in CS either, right? Like as Bjarne was saying, there's like 4 million C++ programmers. I don't think there's a one-size-fits-all for CS, right? So I think for me, the most important thing that I did career-wise was trying stuff out to figure out what I actually like. And I don't see a pitfall in CS. If you want to go do Java instead of C++, do that. That's fine, right? Like I don't want to dunk on other stuff either. So yeah, try stuff out.
So I don't know for sure, but I can't speak to what your pitfalls in CS are because I've never been in CS. And I think that's true of a great many of us up here on stage and probably a fair number of people in the audience too.
So I was a CS student at some point. I was a CS professor for some time. And I teach a course in a computer science department every year to keep my hands in because I hate talking about things that I haven't tried recently. I think the two main dangers are nothing to do with language features. It is, one, teaching people that computer science or system building is easy and simple. And the other one is that it's all grubby, low-level stuff. Those two ways can piss people off seriously.
For me, I would say that there's always a lot more out there to learn. And so for some people that can be like really intimidating and it can make you feel like maybe you don't know enough or you're not qualified enough to do something important or something that you want to do. And so like one part of my advice would be that I think most people have like something really valuable that they can contribute, and like things that they've learned that maybe other people don't know. But then kind of on the flip side of that, it can also be really easy to see, look at all the stuff I have learned, and then kind of stop looking at what else is out there. So like, I guess my advice is like, be confident in yourself, but not like arrogant or overconfident.
I can give you a personal set of information. I started writing C++ in 1992. I learned new stuff today. That's fine. I'm happy with that. I figure if I don't learn something new on a regular basis, I mean, why am I doing this?
I get a fair amount of email that goes as, one of the nice things about C++ is it keeps changing, so I learn something new.
I can give you my perspective from a old CS student. I think one thing that helped me a lot, other than being active in my coursework and my lessons, was finding something I was passionate about and building something on the side. I think I learned more that way compared to the usual coursework. For me, it was video games, so I started experimenting with C++, creating my own small games and projects. But it can be anything. Just find something that excites you, you're passionate about, and that's the best way you can hone new skills and also learn new things.
Marshall, you want to guess how old I was in 1992?
I know how old you were in 1992, Bryce.
Somebody mentioned the style of teaching, and I'll mention two styles. The one I really dislike is, look at this code. It's complicated. You don't understand it. I understand it. I'm smarter than you. Anybody who uses that trick shouldn't teach. On the other hand, I was taught by Brian Kernighan, who said, if they notice you slip the knife in, you haven't done it right. In other words, people should go away from your teaching thinking, wow, that was quite simple. And then, of course, the next course will do more complicated and difficult things. But again, if you do it right, they'll again think that it's reasonably simple. And sooner or later, there will be experts, and they will appreciate the complexity behind it. But you can't start with the maximum complexity.
We're on this side.
Hi, I am Andris Nivchak, and my question is, what can I do when the C++20 breaks my code at runtime? One of the features of the C++20.
Run it in the sanitizers. Same thing you do when everything breaks at runtime the rest of the time. Like,
the problem is complicated.
Yeah.
If the struct is default constructible, if the struct has user default constructor, there is not aggregate anymore, and I use the aggregate initialization to detect if the struct is C++98 pod, plane of data, and I can't use this tool anymore, and there is no more tool to detect if a struct is C++98 pod.
So on the committee, we try really hard to avoid breaking changes, especially those that we believe will affect a large number of users. If there is an issue that is important to you, that you believe would be a breaking change for some significant subset of users, one thing that you could do is talk to your compiler vendor and see if it's possible that they can give you a warning of saying, the behavior of this code will be changing. And if your compiler vendor agrees with you that that will affect a significant subset of their users, then they could implement that warning. And then, like, if it's something that's statically detectable, like the example that you just gave, that could be another thing that you could do to help with the migration.
Or even better, you could write a patch for your favorite open source compiler. and get your hands dirty in compiler internals.
Unfortunately, the Microsoft's compiler doesn't open source, but isn't open source.
True.
Hey, their standard library is open source now. You never know.
I have it on good authority that one can often write Clang tools that will find this in source, even if you're not routinely compiling with Clang.
You could probably even write a Clang tool to automatically refactor your code.
May I just comment to the panel that suggesting that a solution is that one update one's compiler or implement a compiler tool is not an answer for most people?
Okay.
Thanks.
I will take that challenge and say, sometimes we break things and you have to debug your code, and debugging code can be hard. Sorry.
And we need better static analysis tools.
I'll second that. I mean, the dynamic analysis tools have gotten way better in the last 7-8 years, and that's a great thing. The static analysis tools have gotten better as well, but much more slowly. It's a hard problem. Static analysis is a hard problem, but I look forward to the day when we have better tools.
Herb,
and we will get there.
Herb, I think I have to disagree with you. I think a lot of people in the community want us to be able to move faster, to add more features, to fix broken things. The only way we can do that is if we as a community can learn to rely on tools to help us migrate from the status quo, which might be broken in some ways, but to a new status quo that might break people who rely on the old status quo. If we as a community can't learn to rely on tools, we cannot move with greater velocity. And I think a lot of us want to be able to move with greater velocity.
And concretely, there's stuff like this that when I was a developer who was not involved in the committee and did not know anything about compilers, I worked at a company that needed something like reflection. It's something that you end up building, right? It ends up being not great, right? But over time, I think C++ has gotten so good at tooling that this type of stuff is actually trying to be doable by people who don't necessarily know that field, but who know their code. And I think that's key to scaling some stuff, because diagnostics, in this case, diagnostic is very specific to C++, but there's a lot that just aren't. And if you go look at, say, how the Clang tidy stuff works, his team has a ton of stuff specific to Google code, right? And most code is not Google code, right? And I think that's actually key to C++ scaling well.
May I ask, that was the original questioner, right? I know you want to solve your problem. Are you interested in learning Clang tidy?
Maybe, but it doesn't help for me.
He's trying to solve his problem, not be told to go learn how to be a programmer in a new source base and build his own tools. This has actually been a problem in our community, that most programmers, most of those 5 million plus, expect to get tools that work, not to be asked to build their tools. But maybe I don't get out enough.
Yeah, I think there's an important trade-off here that we're kind of discussing somewhat, and it's a discussion that we have pretty regularly in the committee. Is on the one hand, you have stability of existing code, and on the other hand, you have the desire for new features or fixing things that might cause someone else a problem or improving consistency in the language. And it's kind of a situation where no matter what we choose, it's going to be the wrong choice for some people. And we try really hard to kind of get an idea of what effect certain changes will have in the community. So we have like a code search tool to see okay, how many uses of this type of thing exists in the code of like a selected subset of open source tools. But it's not perfect, and we don't have your code probably. So another thing that you could do, which I understand is also a significant investment in time, is to follow the proposals of the committee and say, oh, they're going to break this, and I think that actually will affect us, and then send in your input, and we'll try to take that into account too.
I think we should be careful and work hard. Most programmers cannot fix their tools. They cannot fix their compilers. They cannot download random tools from the web. They cannot afford tools that cost money, and they don't know they exist. And we have to work very hard to make it easier to do these changes. We have to make better tools, make them easier to deploy. This is a long-term issue, but I think the only way we are really going to get to the bottom of this sort of legacy code, old code, bad code, horrible bug kind of stuff is actually code transformation, analysis and code transformation. And yes, it's long-term. Some of you have been hearing me say this for a few years, but the code is out there. It's ugly, it's ununderstood, the tests are not there, it relies on compiler switches we would rather never see, and we need to get rid of it, and the only way of getting rid of it is actually to transform it into something better.
I agree completely with Herb. I think it's unacceptable that we have to tell people, yeah, you have to write a clang-tidy tool to fix your code because we broke it. And there is like the idea here in the panel that we either have to choose stability or to make breaking changes. I think that modules might give us a way out of that. So I don't know if you're familiar with Rust, but they have this thing called the editions, where basically at a module level thing, they can specify what kind of language features they want to be enabled or not. So theoretically, we could introduce breaking changes as an opt-in change to modules, and you as the user would be able to opt in into a new standard and then slowly migrate by moving your modules forward one by one. I think it is possible theoretically. There are obviously some concerns about introducing dialects and making the language more complicated, but I believe that if we do it properly and we have a linear progression of breaking changes that users can opt into in a linear way, module after module, nice slow migration, we might be able to fix a lot of things with C++ and keep the stability of the language, which is a very important feature of C++.
Can I say?
All right. Go ahead.
A solution for my problem is provide the type trait which tells if the struct before that C++20 was an aggregate, but because there is a user default constructor isn't an aggregate anymore. So when you create a breaking change, provide the tool which tells, yeah, there is a breaking change. But before that, it would be work.
I see some furrowed concentration. I believe what you're saying is simply the tool would be, please give me a trait so I can ask if this is a kind of type. So the tool you're asking for, we could provide through Titus's group at Marshall.
Yeah, that would be good. Thanks.
All right. On this side then.
Allow me to ramble for a moment. It'll terminate in a question.
Why don't you start with your name?
Oh, my name is Alex Davis. I really enjoy being here. The company that I get to keep in the hallway allows me to have conversations and let C++ information flow in a way that I would not experience on a typical day. In order to try to update myself to stay up to date with the standard, you talk about being in the future with what you guys are implementing. I live in the past. I use C++ 11 all the time. I feel like that's pretty popular. There's like two whole participles between us at that particular point. I feel like a good way to stay up to date would be to attempt to write stuff for committee submissions. Sometimes it seems like it takes a bit of effort getting in. It seems daunting because of the amount of time it might take. My question, I notice that you all have jobs that do not say C++ committee. How much time do you actually have to spend doing what you do for the C++ community, other than what you do at your regular work. Surely they don't hire you to be at NVIDIA or Apple or Vest to write C++ all day. You have a job and this. I'm just curious as to how do you guys personally accomplish that?
Just lucky, I guess. I actually have a job where one of my job responsibilities is being on the C++ committee. And the position I have on the committee, I estimate at a quarter time. Three working months a year. That's a huge commitment. And I'm really, really lucky that my employer says, yep, I want to pay you to do that.
You're welcome.
Now being a working group chair is a much bigger time sink than most of the people on the committee. So that's an extreme example. But you'll find that I suspect you'll find a lot of people on the committee have worked their way lucked into having understanding employers.
For me, standard C++ is really important to my company. That's why we make a big investment in it. This is a large chunk of my job. I spend a third to a fourth of my time on this, but the reason that my company supports it is because it matters and it has great impact for us.
That's for me. My company supports my involvement with C++ because my company supports me. And C++ is what I want to contribute professionally. But I think for a fair number of people on the committee, they're doing it in their copious free time. They're spending their vacation days coming to committee meetings and hashing out what the next version of C++ is going to be like. And I think that is a noble and professionally giving way that many people work on C++.
So it also depends on what you want to be involved into. Some people are chairs, so obviously they have to sink a lot of time into that. But in my experience, I have a few proposals that I care about, and I wrote my proposal in my spare time, and then my company sends me to the meeting, not just to discuss my proposal, but also because we are a huge C++ shop, and just the fact that there are people there able to come back to the company and teach and tell people about the new upcoming things and prepare people to migrate to newer standards is also very important. And I believe that you can be, morally right and find an intersection of what you believe is good for the language, good for the future of C++, and also for the company itself. So you can get the best of both worlds. But, your commitment has to be personal, and it can be a huge commitment and a small one.
Thank you.
One last. I spend about a quarter of my time doing committee stuff, but I would also argue that even occasional participation on the committee should be a thing that you ideally should be able to sell to your employer, because knowledge is viral and experts are carriers. Like, come get infected. Right? You'll bring it back to your, employer, bring it back to your code base, like, make stuff better. It won't be an easy, clear, did X, we got $10 or $10,000 or I don't know, whatever money matters. And then, there's value in knowledge and expertise. And, we're in a creative profession. Anyone that doesn't understand that, sorry, but you're wrong. So convince your employer. I don't know, watch this video.
I think you'll find it's not as hard of a sell as you think it is.
I have found that most employers will give at least lip service to training and professional growth, and this is one of the ways to do it. A lot of people will say, "Yeah, we're all about professional growth as long as we don't have to spend any money or time," which means we're not. But most employers are a little more generous than that. And growing your own career is always good because you own that.
And you can always find a new employer.
We're
I was
hiring.
waiting for somebody to give Andre's solution. Yes.
Share Andre's solution. What does he always say?
Well, no, it's to find a better employer. Having said that,
he always says, talk to your recruiter. That's what he always says.
that's right. But what Marshall said is a good point. A good technique is say, this is training. That's not going to work with every employer. The good news is that those of you who are here in the room, maybe not those who are watching online but those who are here in the room, probably your employer already sent you here out of training budget. And if that's the case for you, then you are at an employer who already has policies and procedures that are in this direction. So it's definitely worth trying if you're interested in getting involved.
Yeah, and speaking as a chair, the training that you get by participation, in my room at least, is significant, because the thing that I say at several times a day when the committee is in session is, if you are in the room, you have the right to vote. If you don't know what you're talking about, haven't read the papers, aren't paying attention, please don't vote. But at the same time, before leading up to, we're going to take a vote now, I will go to great length to try to restate things several different ways and make sure that, as near as I can tell, everyone in the room has followed along with the discussion, which means in an average week, we're going to go through 50 or 60 cutting-edge C++ proposals, and I'm going to do my best to make sure that everyone sitting in the room understands what's going on. I'm really good at this game now because I've had to teach it for 60 proposals 3 times a year, right? But you can come along, you'll get better.
I think if one of your goals is to get committee participation, well, the easiest thing is to read the papers, but that's hard to track. I did that for maybe 10 years before joining the committee, and it's hard to know what's going on. The committee is getting better at trying to do outreach for groups that don't typically get represented much. And so I think SG14 was the first one that did that very well. And SG14, which is the gaming, low latency, finance, embedded, other stuff group. So they try to convene not necessarily where the committee is, but where that constituency that's underrepresented is.
They'll
at
be
GDC
meeting on Wednesday at CppCon, yes.
And so I think that's easier if that's your group, or just you want to observe, to go to and get started. Try to understand how the committee works, and not. I think we've talked a lot about the stuff you get from it, but I think if you're representing that type of group that the committee doesn't hear from a lot, you have something to contribute in a different type of use case, different type of code base, and SG14's been really good at that. And recently, SG19 is trying to do, machine learning and AI stuff, which maybe you can talk about. I don't know. You guys do that? But I think that's another kind of easier to access thing where, it's Wednesday. You can, if you registered, I guess you can just show up and at least see how that part works, right? I think that's also very useful and less investment of your time.
One thing I will say is that I've spoken to a number of people, mostly new committee members, but some of the older ones, who were surprised that their company said yes. Ask. If you don't ask, your boss is probably not going to come to you and say, hey, you should go to some committee meeting three weeks out of the year. But if you do ask.
One of my ongoing mottos is, if you don't ask, the answer is going to be no.
All right, I think we're over here now.
Hello, my name is Alexander Voronov, and I'd like to ask about the topic which Vittorio already brought up about editions and the breaking changes. I'd like to address the question to the rest of the group. What's your opinion on it? Because currently, as Help phrases it, we can only simplify language by adding stuff, which is a bit counterintuitive. And now it looks like we can change the direction and make things better. And I wonder, how do you see this?
The C++ committee, new proposals go into one of 2 groups. There's kind of the evolution track, which is for language proposals, and the library evolution track, which is for library proposals. And I think the names of those groups are actually significant. It's evolution. It's taking into account where we are and trying to get to where we want to be, rather than throwing away what we had before and starting fresh. Like those are two both like valid approaches for different things, but I think that like C++'s approach is that, like Bjarne likes to say, that backwards compatibility is a feature. And it's a feature that we don't want to give up and create C++1, C++2, C++3. I much prefer kind of the approach we're taking of trying to ensure that people have sort of an easy path, or as easy as possible, of migrating forward, rather than saying, okay, you have to rewrite all of your code now.
I'd like to pour a bit of cold water on the idea of breaking changes coming regularly through maintenance, say, in different versions of modules. We have a very diverse language, implementation, tool, library, culture, and having a series of incompatible changes percolate through a system with hundreds of tools produced by many dozens of independent and often competing organizations is, to say it mildly, a bit hard. Imagine looking at a piece of code and you first have to see what version it is, then you have to figure out what version what that version means. If a piece of code could mean something different in two versions, I have to know everything to read it. I think it's a scale problem, and it would at least be extremely difficult. So please don't get your hopes up.
I want to reply to Bjarne real quick. That is already the case with standards. As we have seen, standards have different meanings. So you cannot just look at a piece of code and understand exactly what it's doing. As we've seen with the previous question, aggregates are completely different between 20 and 17. So it already changes with standards.
It's not either or, it's a matter of scale and magnitude.
I do think we have to be, speaking as a devil's advocate here, I do think we have to be careful here. A large part of the success of C++ has been its stability. And one of the reasons why we have such a dedication to stability is because many of the major vendors and the actual implementers of C++ hold us to that. And I think the implementers are often the ones who best know what their users want and need. So when all the standard library vendors tell us, well, we can't do this because it would be a breaking change for our users and it would really impact them, that's because they've experienced it.
I would like to give a specific example here of a breaking change. When C++11, we added a set of requirements on std_string that basically outlawed the ability of an implementation to provide copy on write strings. And this was done for good reasons, and they were compelling. And fortunately, I didn't have to live through that because working on libc++, we started with a non-copy on write string, but the libstdc++ people had to change their string implementations. This was in 2011. They are still paying for that. They are still suffering the pain of that change 8 years later with incompatibilities. And I see posts on Stack Overflow. I built this library. I got this library from here, and I tried to put it together. And when I run it, it crashes. And here's the backtrace. And it's like, oh, yeah, you built this. This one of your shared libraries is built with the old string ABI, and this one is built with the new string ABI. How can you tell that? Well, I've just seen this track trace before. Seriously, 2019, 8 years later, and I feel bad for them because they're still hurting for it. And so nobody really wants to do that again. Nobody wants to set off a decade long of pain.
One thing that I want to kind of clarify from what I said before, I'm not saying that I don't believe that we can, or let me rephrase that. I believe that we can continue to make large changes in the language that dramatically improve and simplify things. The point that I'm trying to make is that I believe that the path forward is to evolve our way there rather than to throw out what we had before.
I think there's been a lot of misconception about what I've been proposing and in general the idea of editions. I hope to clear this misconception when I'll have a paper that everybody can read. But what I want is not something that could break ABI or could completely change the language or could introduce dialects. I want something that, for example, allows me to change the language so that I cannot write an initialized variable anymore without some explicit syntax. I want something that allows me to change the language in a way that implicit casts cannot happen anymore and people are forced to use static cast to help readability and newcomers to the language. All of those things would be impossible today because making that change would invalidate existing code. But if we had a way of allowing people to, now we switch to C++ 23, and at the top of my module, I just say, yes, I want to obtain into C++ 23, then we could change these things and make the language safer and easier for newcomers to come to without sacrificing backwards compatibility. Replying to Marshall and to the others, I think that what I envision would not create problems. It would actually prevent problems like the ones you described from happening.
And I completely agree with you. And so one of the things, I think that we do need to move faster, but for us to be able to move faster, we need a plan. We need a long-term plan of how we're going to be able to introduce new changes, something like what Vittorio is planning. I think that this is the thing that we've been waiting for. We need a strategy. We can't keep just saying, oh, it'd be nice if we could move faster, but we can't because, we can't break things. If we want to make change, we need a plan.
All right, now I really have lost track. Are we on the right?
As software engineer, maybe me, I don't know, maybe some of us strive to have readable code that is very easy to understand by people who have never seen it before. Is there any effort to do the same to the actual standard to make it more readable?
Can you tell us your name?
Oh, Victor. I'm Victor.
I'm going to pretend you said standard library and not just standard. Because that's what I work on. The problem is, from that point of view, is that people in general don't look at the sources of the standard library. Some people do, but mostly people care to say, does it perform well? Does it do all these things that I expect it to do? And does it not conflict with my code? And unfortunately, all three of those are sometimes in conflict with the idea of making it simple and beautiful. If you come to my talk on Friday, called Stood Midpoint, How Hard Could It Be? I will show you an example of something that should be beautiful and simple, and that there's really good reasons why it's, what were you thinking when you wrote this? So from a standard library point of view, people really want, I've heard feedback, people want performance, they want functionality much more than beauty.
The standard's not a user manual. I think it's important to keep that in mind.
Yeah, and as much as it would be great if we were the paragon that you should be aiming towards and like the virtuous, like the, no. Because the complexity of what the standard has to be is so much higher than what anyone else is actually going to be fighting with, right? We have to be no overhead. We have to be compatible on all platforms ever. We have to be backwards compatible for as far back as we possibly can, right? Like the delta between the design for the oldest types in C++ as they exist in the standard and as we would do it over today is non-trivial, right? Pair, tuple, locale, IO streams, we could go on. Valeray, vector bool, right? Like, we just have a different legacy problem. So it's always going to be a little messy. Sorry.
Writing a clean, clear specification is a very rare skill. And we have really good people in the committee, but we are not all really great. There has been attempts to rewrite sections of the standard to be clearer and nicer. They have not been uniformly successful. Partly saying the same things more clearly and simply is hard because we have to be bug compatible.
I will say that it's also a fairly new art to write something like what we're writing. People haven't been doing it very long, and 50, 100, 200 years from now, people may look back at our experience and have figured out how to do this much better than we do now. I hope they will. Perhaps they will still call the language C++ then, but it will be a very different thing.
I think to answer your question, I'd go back to how I introduced myself, which was that I try to look across different groups and different features. I feel like some of the complexity in the standard comes from people looking at their feature and not looking at how it integrates into the broader language. So we have to specify, this is how this feature works in this case, and this is how this feature works, and this is how these features interact. And I feel like if we could spend some more time trying to look at what is the standard library impact of this feature and how do they work together? How do these features integrate with each other? Then that won't necessarily help us with the things that are already in the standard, but the things that we're adding, I think, can be specified more simply if we can define the semantics more uniformly.
I will just say that there are some parts of the standard library implementation which are a joy to read. And I'm not speaking specifically of my implementation, I'm speaking in general. Some of the algorithms, you look at std copy, and it's like, oh yeah, that's really simple, or find if, or so on. But when you get into the things like vector or something that have to do a lot of things very, very carefully, it gets complicated and it gets much harder to understand.
All right.
I will say that I know of one C++20 feature that has shortened quite a few pages out of your standard library spec, and that's Spaceship.
All right, I think we're over here now. Can you say your name?
I'm Frank Vasquez. I want to know if meta classes are on the fast track for 23. And if that's not a fair question, I realize that it isn't. What other language features need to land before meta classes can happen?
You asked exactly the right questions. So
how much did you pay him?
It is. What was your name?
Frank.
I don't know if I know you. I can't quite see, but it's a good question. It is premature to talk about virtually any feature as for being C++23. We hope we'll get reflection maybe in that time frame, or maybe a serious progress on it. I'm not at all concerned. I think things are going along, to use the international English term, tickety-boo. They're going along very well. In particular because the key things, if you saw Andrew Sutton's talk earlier today, for example, reflection and injection or generation are the things that as soon as you have those, that's 95% approximately of my original metaclasses paper. It included all that because those things didn't exist. I wanted to do the icing, but I had to also try to build a motivation to build the key engine on which it would be built. That is now progressing very well thanks to many people working on them. As soon as we have reflection and generation, metaclasses become essentially a syntactic sugar for applying a certain compile time function to this class as I'm writing it. It becomes a very light sugar, I think still a very important and useful sugar, but once we have reflection and generation, we've got 95% of the metaclasses proposal. And those things are moving along well. That's not a one-year thing, but it's in progress, and I'm very bullish on it. And it's thanks to the efforts of many people who are making it real and possible.
Thank you.
All right, over here, please.
My name is Gabriel Obulusi. I've been working on a draft called, and it's inspired from another paper called Leaving No Room for a Low-Level Language with Fewer Warts. So other people have beaten me to the punch by talking about the idea of C++ epochs, which is relative to the Rust ones. What I was wondering is now we can take a different angle. So how long can we expect C++ code to be used to create new projects if we cannot fix our mistakes?
I think you bring up an important point, which is basically that a programming language, it follows kind of the same rules as like any organism, which is that it needs to continue to evolve and adapt to the situation in the environment if it wants to survive. But I think that C++ actually is doing a reasonable job of cleaning up some of its mistakes. Like, it's not necessarily in the form of deleting the old thing. Like, the preprocessor still exists. You can still say pound include, but we give you the ability to say import. Like, our focus is more on providing you the tools to express your intent clearly without any unnecessary overhead. And then you as a user have the ability to use many of the existing tools out there, like static analysis tools, compiler warnings, compiled coding standards, things like that, to kind of selectively remove some of the features with sharp edges that may have been supplanted in newer standards.
I'd like to echo that. Traditionally, we have moved forward by providing superior alternatives to what was in the language before. And on a couple of occasions, we've tried to get rid of the old stuff because we knew it did harm. And each time we've found that it could not be done. There was always a few 100,000 people who depended on this obscure detail that we really didn't like and knew did harm. And they forced their vendors to have compatibility switches, backward compatibility switches, and have them backward compatible by default. If you can look at the list of things we try to deprecate, it is a sad story. And so I expect something similar to happen again. So we move forward by providing better alternatives, by encouraging people to use the better alternatives, to provide guidelines for using the better alternatives, for providing tools that enforce these rules. And eventually, I hope we get to the code that can discover the old bad ways and transcribe the code into the new versions. We are not there yet, but I think we'll get there. And I think banning things or making incompatible changes is a demonstrated loser over the decades.
Yeah, I think it's important that when we standardize better tools, we're not afraid of having them not be 100% compatible, because there's this word that some subset of people use. I think we do have to try to have the better tools that we like to have standardized in the first place. Like, our value references aren't just a thing you can swap into your code automatically, right? But they are a much stronger tool than what we had before. And I think if you want to look at the state of the art of what's done, maybe looking what the people who write the tools end up doing might be a good good way to see like, well, could I do better? Assuming that we know how to use our own tools. And recently the LVM code base moved from C++ 11 to 14. I know it's kind of embarrassing, but we just did. And that migration was mostly manual, right? Like a lot, there is tooling that exists to upgrade certain constructs, right? And there's stuff like you can auto upgrade range-based for loops if you're moving to 11 and things like that. But even then, a lot of the migration ends up being not just automated tooling, but it ends up being humans who left it to do, like, I really got to do this a completely different way if I had this tool or something like that. So I want to disagree with Bjarne that like tools can't exist to do this, because there's key tools that can, but I would hope that we'd be able to create better tools. I want to disagree with you on principle because I want to believe that it's feasible. I'm afraid you might be correct. But yeah, I don't think there's a really nice way of doing that. And so what that really means is right now the state of the art that I've seen is you're kind of stuck when you upgrade languages and having to do it manually, having to like move your code increments at a time, which is where I think Vittorio is trying to aim at, of making it easier to do point places where you change stuff. But it also means that you have to own your code, right? Like I've worked in code bases where like nobody knows how that part of the stuff works. And so if you don't own that part of the code and you're not kind of constantly like massaging it, improving it, and doing stuff, I wouldn't trust a tool to touch it automatically either, right? So I think owning your code is a big part of that upgrade mechanism.
When I was doing experiments with this, I usually classified things as things that cannot be done in the cleaner modern way, things that can, and things where the tool can't figure it out and calls for a human. You need all three.
I just want to say that you touched a super important point. And it's not about cleaning up the language, but it's also about I'm starting a new project, or I'm creating a new module for an existing project. I don't want to have all this baggage that's been there for 20 years, because if I have the choice between using C++ and using a brand new language, I won't choose C++. I do technical training at my company, and I've also done it at CppCon, which was a great experience. And when I teach people that in 11 we have uniform initialization, however, we still have all the other ways to initialize variables, and there are some pitfalls with uniform initialization, my heart just sinks because I can see that in their eyes, they think, how is this possible? How did the language get so complicated? And why would I ever choose C++ since initializing a variable is so difficult and requires a lot of thought? I think that we need to like, something that Bjarne says is that teachability is super important, and we want to keep things simple. And if we want a new audience of young programmers to get close to C++, we need to at least consider something like additions or epochs and a way to erase outdated ways of doing things and allowing people to have safe by default, easy by default, without having to care about all the baggage we added in 20 years or 30 or more than that.
All right, on the left then.
Hi, my name is Domagoy, or Patrick in English, if that's easier. Slight trigger warning. I have a bit of a stingy and a lengthy question, but it has a point, so please bear with me. As far as I know, there's the SG14 working group. That's all about the high-performance, embedded, game dev, low latency stuff. And doesn't the very existence of that working group sort of prove or point to the fact that the committee has failed one of the core missions of the language? That is, the C++ language was supposed to be all about that. We had the failure of IO streams, where for outputting a single character, all the compilers, it's just a bug in the language, not just in the compilers. They generate a mind-boggling amount of instructions. But unfortunately, this is still happening even with the newer features of the language. One of my favorite examples is stud function, for example, which forced me to write a completely new library. It's called Functionoid on GitHub for all the others that have the same problems. For example, stud function will force RTTI into your code. So each lambda that you put into stud function will cause the type name of that lambda to be encoded into your binary. Not only does that increase size, you might not want that. That leaks your internal source information. You can specify that the call operator of the stud function is no except. You can say, I don't want a copy construction, so that the vtable doesn't contain that pointer, for example. You can say, I want a move operator. You can say, I'll only store, for example, trivially destructible lambdas inside it, so it doesn't have to have a destructor pointer in its vtable, etc., etc., etc. This is all solvable with Andrei's policy-based design. Other examples are, for example, the threading part of the standard library. Herb, that goes to you, because I mostly do my programming in Visual Studio. The Windows kernel, for example, has really great threading building blocks. They should practically map one-to-one with the C++ threading concepts. Yet if you check the code that your compiler generates for working with threads and mutexes, it's just mind-boggling. It's like, what on earth are you doing? Why don't you just call create thread? I don't know, it heats up the room before it creates a thread. And also, a side point, your compiler still has crashes with expression-based no excepts in my functionoid library, so we can go over that tomorrow. Quite a while ago, on the Boost mailing list, there was a discussion about this regarding shared pointer, where Peter Dimov, siding with the other side of the argument, said that parameterization discourages use. This was sort of his response to my objection. Why do I have to pay for RTTI and virtual function calls even for something as a shared pointer? Because the shared pointer supports dynamically typed destructors, which is probably used by 0.1% of people that use shared pointers. And it also stores type information for the destructor of it.
So you've raised a lot of points. You've also run us out of time.
Okay.
So, so I do want to give a little bit of time to respond to that, but we're out of time, so we need to wrap this up.
I'll finish in 10 seconds.
Go to the Visual Studios, the Visual C++ booth with those questions. The experts there can tell you. Billy, who was sitting over there a moment ago, can answer many of your threading questions. The RTTI stuff, see Andrew Sutton's talk earlier today. If you weren't there and don't have a time machine, YouTube will be there, and he'll talk about that. I'll also touch on type ID and RTTI overheads in my talk on Friday. I think your basic question was, why do some things still have overhead? And so they do, either in the standard or in some implementations. They are generally efficient enough for most people to use, but there are going to be some demanding use cases where you will use a custom thing. And in general, SG14 started with gaming in particular and with finance, and that the whole committee does care about zero overhead and mostly achieves it. Although depending on your specific use case, you may not find that to be true in your case, and you may reach for something else. But come on Friday and we'll talk a bit more about RTTI and getting rid of it.
So I worked in finance for 6 years, dealing with processing streaming financial data, where we cared very much about throughput and latency. And an interesting thing about that domain is that there is almost always a trade-off in throughput versus latency. Like if you want to write a concurrent queue, the highest throughput concurrent queue will not be the same implementation as the lowest latency concurrent queue. So a lot of times there's more than one aspect of performance, I guess is what I'm trying to say. Like you could care about battery consumption if you're running on a mobile device. You could care about, relatedly, power consumption in servers. You can care about latency if you're in a game dev or audio processing or finance sort of environment. Or you could care about throughput if you have batch data processing. And like, to me, the goal of C++ is to provide you the ability to write tools that solve these problems and to provide tools that cover the 99% use case and like allow you to get that last 1% when you're in a situation where the standard tools don't work for you, because it's not possible for us to write a tool that is the fastest for the definition of fastest that you care about in all use cases.
But I'm saying that it is. For example, for stud function, you can only you just make it policy based and default the parameters. And
but that also comes with trade-offs.
Yeah, and by and large, you're right. Std function is in fact my poster child for mistakes were made, and our stability policies prevent us from fixing them. I could add to your list of things that are broken in std function with a fair number of things on my own in the type design space. Fundamentally, we are like in this week and last week going through some of the anxiety of deciding whether or not, like, are we continuing to state that this is a language that prioritizes performance above all else, even though, demonstrably, our voting patterns show that we are prioritizing not breaking someone that built their code against the definition of std function 8 years ago, right? And that is nerve-wracking and anxiety-inducing because there are no good answers to this question. And the unfortunate scenario with std function, the best answer that we have right now is, well, we didn't quite make the C++ 20 cutoff, but there's a better, like, actually trimmed down
My
thing
question was
coming.
actually, sorry, a bit more stingy in a sense. Why was it even voted in the state that it is?
Because
why
mistakes
didn't anyone
happen.
check the code gen that it gets generated for it?
Because mistakes happen. And you're not going to know every platform. You're not going to know every use case. And it was a long time ago.
So you asked whether whether the existence of SG14 is an indication that the committee has failed, and my answer is no.
SG14 is not a failure. It's a sign that we're trying to address issues.
All right, we need to wrap it up there. I'm going to say that the people on this panel are approachable, and they're going to be here. So for those of you that weren't able to get your questions asked, there's still opportunities in the rest of the week. And I want to thank all the members of the panel, and I want to thank those of you who did ask questions, and those of you who were here to share with us tonight. Thank you very much.